have Achim, the chief scientist from the International Fertilizer Association. We have Sijbrand, our CEO at Proba, and we have Konstantinos, our sustainability engineer at Proba. And, without further ado, let's have Achim start us off.
Yeah, so I just want to make a very brief introduction on why we're doing this. I'm assuming that most of you know the numbers, but just as a sort of the big picture background, we have about 660 million tons of CO2 equivalent greenhouse gas emissions that arise from the use of fertilizers in the field. To a large extent, that is in the form of nitrous oxide, direct and indirect emissions. So that constitutes a bit more than 1% of all of the global greenhouse gas emissions annually. And it's a concrete section that we believe we can address through a range of approaches. You can see on that slide here, I don't need to go through the numbers, but either through the way we manage fertilizers in the field or what form of fertilizer we use, or in particular also the use of specific enhanced efficiency fertilizer products. And so in this case, we are primarily interested in inhibitors, so nitrogen inhibitors that block pathways that lead to one way or another production directly or indirectly of nitrous oxide as the most potent greenhouse gas. And those inhibitors, often also when used together, can have a pretty high effectiveness. Move on, please. So the other point to make is that compared to other options, this is perhaps also an option that is quite cost efficient in terms of mitigating greenhouse gas emissions from agriculture. Also, you can see a number of the estimates here. And we have the advantage that we have products, inhibitors on the market for decades already that have proven effectiveness. So this is just an example of meta-analysis studies that have been published in recent years showing for the different categories, UI is urease inhibitors, NI is nitrification inhibitors, UI plus NI is the combination, and CR is controlled release fertilizers. That, by and large, in many situations, they will reduce N2O emissions in the range of 20, 30, 40%. So that's the potential that we're working with. And the other advantage they have, next slide, please. They are actually already available. So, and they are both commercially available, but also relatively easy to adopt because in principle, it is easily possible to apply them in various ways with existing fertilizer products. So we don't really have to change a lot in terms of products or in terms of behaviors of farmers and how they apply fertilizer. It's an added value that could be easily leading to direct emission reductions if we can find ways to make this attractive for farmers. And so the bulk idea behind our project here is that if we can find a way to, on one side, enable sustainability reporting of companies that make inhibitors, so that they can take this into account in their reporting. And the other application that we had in mind from the beginning is to tie the use of inhibitors to voluntary carbon markets. And the basic idea there was, and that's to be tested whether it will ever happen, but to essentially say if we can find a way to monetize proven greenhouse gas reductions and N2O reductions by using inhibitors, and a substantial amount of the money that can be generated from carbon payments goes back to farmers, it could lead to wider adoption of these products. It has the environmental benefit then. It offsets the economic extra cost for the farmer, may have some extra yield benefit, and it would provide a much bigger incentive also for the industry to develop more of these products and have essentially in the future many more fertilizers equipped with these technologies. So that's the fundamental assumption behind this project. And the last slide for me. The good thing is that for farmers, it would not really require a major practice change. So if we can do the work for them, come up with a reliable methodology and the market-driven mechanisms to then benefit from, it'll be not just a win-win situation, it may be a multiple win situation. Over to you, Sijbrand.
Yeah. Thank you very much, Achim. Hi, everybody. Good afternoon, good morning, good evening. Thank you for presenting this to us. First of all, I want to kind of acknowledge that there's currently 450 people who signed up for this webinar. So I think it's a very positive sign that from all over the planet, people are apparently somewhat interested in this topic. So basically, from all over the place. So I don't think there's many, conversations that happen at this global scale. So that's something I think that is really interesting to acknowledge. And also thanks for everybody joining and having this interest. And also thanks to IFA to providing this podium. I think it's pretty unique that everybody's actually here also in these pretty crazy times. So again, thanks. So quickly so the aim of the methodology and our colleague Konstantinos will talk more to that, is to kind of create an incentive mechanism to reduce the emissions of fertilizer use. So that's so basically incentivize the use of enhanced efficiency fertilizers, and nitrogen stabilizers are one of the enhanced efficiency fertilizer products. So we can go into the next slide. I'm reusing, with permission, a slide from CVA. They presented last week at an IFA conference where they showed that fertilizer-related emissions are amongst the most. If you look at the baguette, so a French bread, 40-50% of the emissions related to creating this bread are directly or indirectly related to fertilizer emissions. And a big chunk of these are related to emissions that happen in the field. So outside producing the fertilizers, which happen in the factory, many of the emissions are happening on the field. And again, stabilizers seem to be a good way to avoid or reduce these emissions. Next slide. So there's some magic here, we think, where if you would introduce or adopt more stabilizers in the field, typically they can achieve, let's say, between 20, 40, sometimes 50% of N2O emissions reductions on the field, which has a significant effect on global warming potential. So we think this is a mitigation measure that we should all be looking at, and hopefully can incentivize using the toolbox that we are going to create here as part of this program together with the industry. So the idea would be that we have more adoption of these nitrogen stabilizers by using the incentive mechanism. The benefit outside, less greenhouse gases, is that it also introduces Scope 3 emission reduction claim for both the food companies who are operating downstream, and the fertilizer producers who are operating upstream from the nitrogen stabilizers. The ultimate goal would be to increase the adoption rate of stabilized fertilizers. And currently, for instance, in Southeast Asia, just as an example, stabilizers are used less than 1% of all the urea that is being used there. So there's, I would say, great potential there, we think. The incentive mechanism itself, at Proba, so that's our company, we think insetting is a great way to kind of align interest here, incentives here, where downstream companies or supply chain companies can co-finance basically the interventions that happen at farmer level. And with the support of the industry, the voluntary carbon markets or carbon finance can increase the adoption of nitrogen stabilizers. which is kind of a separate way of looking at this concept if you compare it to the more conventional offsetting way of well, introducing these kind of interventions. Anyway, if you do these interventions, and if you want to make carbon finance work, both in an insetting context, but also within offsetting, there's a few ingredients that need to, well, be there. So first of all, and that's the topic of today, you need to have a very proper, credible, science-backed methodology in order to support the quantification and verification of the actual impact. So that's what we'll be talking about later in a few minutes. Other deliverables, instruments that we will create along the way, the next couple of months, is that we will create a database with emission factors, which is kind of an improvement compared to the IPCC database, which is currently available. We'll make sure that there's strict governance there, so everybody knows what's happening. But we also are going to create a reporting and claiming guidelines in line with SBTi and Greenhouse Gas Protocol. For today, so that's our question. And again, we're super happy that so many of you turned up today. We need feedback because in order to create this science-backed methodology, making sure that it's credible, that we don't miss anything there, we need the feedback from the industry, from people who are maybe hopefully going to use the methodology, but also from the scientific community. So the more feedback, the better we expect the methodology to be, which is super important. So quick summary after today, hopefully. So we will again share the presentation, share the recording of this webinar, but also share again the methodology itself. We like to get feedback from you. We will use the feedback to improve the methodology as much as possible in the weeks after, and make it very transparent on what we did with the feedback before we formally publish the methodology again. Finally, hopefully, it will also create some interest from you to actually start using the methodologies in interventions that can happen, basically all over the globe. I think that's my last slide. I hand it over to my colleague, Konstantinos. Thank you.
Right, it should be fine. Thank you, Sijbrand, for the introduction. And before I start, I would also like to thank Achim as well for taking the time and being here. And I would also like to welcome everyone who is here. And I hope we can make good use of your time. So this is the third and last, but biggest part of this webinar. And as Sijbrand mentioned, the goal is basically to get feedback on the decisions that we have made in this methodology that we have developed, which is focused on nitrogen stabilizers. Now, for you to be able to give us feedback on the methodology, it is important for me to present you the context and the challenges that we have in developing this methodology, as well as the difficulties related to nitrogen stabilizers. So this is the first thing that I will do. I will present context on the decisions that we have made. Then we're going to present actually the decisions that we have so far. And then we're going to open up the discussion to receive your questions, feedback, and comment through the Q&A session. So without further ado, the first question that you might be asking is actually, what is even a greenhouse gas methodology? Put it simply, it is a set of rules that can help us quantify and verify the emission reduction or removal impact of a greenhouse gas project. What is a greenhouse gas project? Well, to put it simply, it is an intervention aimed at reducing or removing emissions. So these kind of methodologies have, in very broad strokes, three main components. One is we need to ask what kind of projects are actually applicable and what kind of products are eligible, so that we are sure that the emission reduction that we are claiming is actually happening. The second one has to do with the method of quantifying the impact. And here, there are a lot of options. You can do direct measurements on the field. You can take emission factors based on previous studies and many other ways. The tricky part is quantifying the impact in a way that is as scientific as possible, and we are incorporating all kinds of uncertainties that are there. The final one, but very important one, is giving guidelines for reporting, monitoring, and verifying that the impact that we're claiming is actually happening. And this is important because if we want to create something that is credible, a company, a third party must come in, a validation and verification body that checks that everything that we're claiming is actually happening. The guidelines that we're putting there are very important because we need to be as scientific as possible, but at the same time, we need to be practical and scalable. More on that in a bit. Now, I want to talk to you about nitrogen stabilizers and how those work. But for you to appreciate them, maybe very quickly, we need to talk about why we need them. And the reason we need them is basically because we're using fertilizers, which are a very important tool. However, now, to grow crops and plants, nutrients are needed. And even though in the soil and the air there are nutrients, to reach the crop growth that we want, we need to add extra nutrients. And this is exactly what we're doing as a society. Farmers are adding large amount of nitrogen and other nutrients containing fertilizers. However, the problem is that typically only 30 to 50% is taken up by plants, which means that the remaining 50 to 70% go somewhere else. Where? Well, to answer that, I will show you this a bit complex graph, which we do not need to get into very much detail. But in essence, the idea is that by placing the fertilizer on the fields, it gets transformed into different forms through processes such as nitrification and denitrification. But this nitrogen, even though some of it goes, of course, to the plants, which is something that we want, other parts leach, for example, and lead to eutrophication. Others lead to direct nitrous oxide emissions, and others are volatilized in other forms, such as ammonia, and later get turned into N2O emissions. The problem is, how do we reduce those direct and indirect N2O emissions, which are very potent and lead to a greenhouse gas impact? Well, with that short introduction, I hope that I made you appreciate the fact that nitrogen fertilizers are a powerful tool and we need them. However, it is a double-edged tool. Enter the nitrogen stabilizers, which, what are they? Well, in essence, they are additives, which are designed to improve the efficiency of this whole system that I just presented to you. Essentially, improving the nitrogen use efficiency, making sure that the nutrients, specifically the nitrogen that we put in, gets more into the plants and less leached or volatilized. How they do that? Well, depending on the type of nitrogen stabilizer, for example, urease inhibitor or nitrification inhibitor, the process of which this is impacted changes. We do not need to get into detail into what is happening with the microbes, but in essence, nitrogen stabilizers help by slowing down the key soil processes, thus leading to reduced emissions. And you might be asking, well, that's great. Why are we not using them widely? Well, there are challenges, except for the fact that they are expensive. There are some specific problems, especially when we're talking about quantifying their greenhouse gas impact. What you see here in this graph, it is from a meta-analysis study, which means that multiple scientific papers were taken together by a scientific team, and then the results were taken together and presented. What they examined is basically the effect of different environmental and management practices using nitrogen stabilizers have on emissions. and specifically N2O emissions, ammonia volatilization, and crop yield. What you can see here is the different types of stabilizer products and their effect on ammonia volatilization and N2O emissions. On the right side, you can see that the emissions are reduced when we're applying the stabilized version of a fertilizer compared to the typically applied fertilizer. And this is the case, more or less, for every kind of product. However, the ammonia volatilization sometimes can increase instead of decreasing when we're applying this kind of stabilizers. So we need to be very careful. The second challenge is that depending on the specific management practices that we're doing on the field, the quantification of the emission reduction can be different. Here you can see some examples from the same study. You can see the inhibitor or stabilizer application timing, the fertilizer source, the fertilizer placement method. All of those have a significant impact on what the actual emission reductions are. And the story doesn't stop here. It is the same about the environmental factors as well. So precipitation, temperature, soil type, all of those affect the emissions that we can claim. So when designing these kind of projects, we need to be very careful when, where, and how we place these stabilizers. Now, the next question is, okay, but why does this specific greenhouse gas methodology matter? Sijbrand touched upon this when he spoke earlier, but I think it's important to reiterate the fact that if we manage to get this greenhouse gas methodology right, then we can drive increase adoption of these nitrogen stabilizers. And we can do that in the areas and situations where we know that there is an actual impact, positive environmental impact. If we do that, then we can unlock the second benefit as well, which is essentially enabling credible Scope 3 reporting across the entire value chain, or as it's called here, the agri-food supply chain. So if an intervention has an impact on the field, then upstream or downstream, a fertilizer company or a food buyer can claim the benefit as well. And the third one is very important. It ensures permanent climate impact. I want to stress this a little bit because there are other types of interventions that this is not the case. For instance, when we're talking about carbon storage or sequestration, for example, when we're growing trees on a specific land area, this can get reversed. If, for example, the trees are cut down or burned, then this is a reversible change. But when we're talking about an intervention such as replacing fertilizers with their stabilized version, then we're talking about an emission reduction, which once it happens, it's permanent. So this is the carrot, let's say, at the end of the line. This is what we can get. And the question is, how are we developing the methodology to make sure that it is both scientific and practical? Scientific, because we want to make sure that the goals, the claims that we're making are true and credible, but practical as well, because we want this to be applicable to many situations and practical to be scaled up efficiently. Well, to do that, we have a few mechanisms in place. First of all, we have included a scientific committee of now 4 professors who have been helping us improve and design this methodology. Secondly, we have gotten feedback from various players within the industry of fertilizers and stabilizers who know what exactly is happening on the field and they understand the difficulties with these kind of projects. Then we have already done an expert review of the methodology by asking a validation and verification body to give us feedback on how this methodology can be exactly scientific and practical and realistic. And now we're on the fourth and final step, which is the public consultation, which essentially means that we have opened up this discussion to anyone to give us feedback, which is done in two ways. One is through this webinar, but more importantly, we hope that this extends beyond the webinar and you can give us feedback offline. All of this process means that we have made, up until now, certain design choices for the methodology, for which we need your input. For those design choices, up until now, we have iterated a lot, and we understand that there are benefits and challenges with those. And of course, those can be reversed or changed. And this is exactly the purpose of this webinar and this public consultation. So we want to hear what you think. And I hope that up until now, I have provided you with the necessary context to be able to understand why we made these choices. So the first one has to do with the applicability of the methodology. As we said before, the rules, guidelines as to when a project is applicable to be quantified using this methodology. So applicability is based on the availability of scientific evidence. This sounds very logical, of course, but in other types of greenhouse gas methodologies, what's typically done is that they restrict the options to a few certain cases. For example, we could say we will restrict the methodology to be applicable only to specific nitrogen inhibitors and keep it there, because we know that about them we have scientific information. But what we decided to do is keep it a bit more open, because we know that this kind of scientific area is constantly getting updated. So we want this to be a dynamic, in a sense, methodology, where in the future, if more scientific evidence comes up, then this means that this can be included as well. On the other hand, this also means that if for specific management or environmental practices, there is no scientific evidence, then we cannot claim any environmental impact. The second choice that we made on applicability has to do with the baseline, which we require that it starts from good farming practices. And more specifically, what we mean here, we're talking about the nitrogen use efficiency. We do not want to reward farming practices that are over-applying nitrogen. And because they are doing that beforehand, when they apply the nitrogen stabilizer, they have increased impact, which means that the impact is overestimated. That's something that we want to avoid, because we want to have credible and real emission reductions. And we want to reward farmers and practices that are already doing good practices, and not reward those that have been not doing such practices. The third one has to do with the nitrogen application rate, the reduction of which is currently out of scope of the methodology. Now, this is a little bit counterintuitive. The reason for that is because these kind of programs typically prefer the reduction of nitrogen application rate as part of the intervention, because it is something very real. You can actually very credibly measure the impact of the product carbon footprint of the nitrogen fertilizer that you're placing. So if you're applying less, this is straight away a very real benefit. However, we decided to keep it out of scope, mainly because of the scientific limitations that we're having currently. The effect of reducing the nitrogen application rate when using nitrogen stabilizers has not been studied thoroughly yet. So going from 100 kilograms of nitrogen per hectare to 80 and at the same time adding stabilizers, of course will have an impact, but the quantification of which, based on concrete scientific evidence, is not there yet. And this has been stressed by the scientific community a lot, for example, by Fan and Al. And when we have more information about that, it is a very welcome update. But for now, it is out of scope. The next design choice that we made has to do with the greenhouse gas sources. And what we say here is that only direct and indirect N2O emissions are accounted for using this greenhouse gas methodology. For this, we got feedback actually from the expert review. And what they said essentially was that similar kind of programs are requiring that you do a full accounting of all the kind of emissions that are happening on the field. CO2, N2O, and methane, any other. However, there are two things here that we considered. One, we wanted to keep this methodology very, very focused on the nitrogen stabilizers and the introduction of those into the farming practices. If any other practices are happening which can increase or decrease emissions, then those must be accounted for. So the second thing is that we require transparency when such extra activities are happening to account for those emissions. So two things. One, only direct and the indirect emissions must be accounted for. But if other practices are happening as a result of the introduction of the stabilizers, then we require project developers to be completely transparent and account for the others as well. The third one has to do about spatial boundaries. So typically, similar methodologies are focusing on the left side, so the land management unit kind of boundaries. For those, what it means essentially is that we have access to farm level information. We know who the farmers are, where they are, and we can easily ask for a verification body to go there and check what is happening. This is very traceable. And because we know what is happening on the field, we have lower uncertainty of the emission reductions that we are claiming. And on top of that, what we're saying here is that we allow additional practices to happen, provided that we have scientific backing for it. What we have heard as feedback is that by this last point, we might open Pandora's box, as we call it, of different interventions, which can complicate things a lot. However, to solve this, is that we try to be very strict on the scientific evidence that is provided if you want to do an additional practice. Now, what we wanted to do with this methodology was make it more practical. And for this reason, we added the sourcing region kind of spatial boundary. This is for the cases that we cannot have access to farm level information. This is a more scalable approach. However, it comes with a cost, which is essentially a higher uncertainty deduction, which is caused by the more uncertain, let's say, emission factors that we extract for those generalized situations. What I mean by that is that from the literature, we have very specific emission factors that we call them, which are for specific management practices and environmental factors. If we start grouping them, then we can aggregate them. But when we're doing this aggregation, increased uncertainty propagation happens, which reduces the possible impact that you can claim. And this, we state in our methodology, is and must be an interim approach, so a stepping stone towards going to more granularity, towards going to higher traceability, so going towards the land management unit. So this kind of approach of having both approaches, but steering towards the land management unit, is also aligned with the directions given by other bodies such as SBTi and the Greenhouse Gas Protocol. The next decision that we have made has to do about how do we ask a project developer to define their baseline. And by baseline, we mean what is your starting point of the reduction that you're claiming. And here we state that it is based on a counterfactual approach rather than a historical. For those who are not familiar, by historical approach, we mean, for instance, if last year someone was using a car, for example, with a combustion engine, and then they decide to switch to a low carbon electric vehicle, and they're using green electricity to power that, then last year would be their baseline, and this year is what they're doing. So the reduction is based on a historical baseline. But then someone might come and say, well, yes, you're doing that, but in your region, everyone else has switched to electric cars. So this is a regional kind of baseline. But what we are saying here is that neither of those approaches is applicable for the realities of the farming industry, and we require a counterfactual approach. Every year, the farmer has a choice to make as to which crops they will grow and what kind of fertilizer they will select to do that. And based on the prices of the crops and the fertilizers, they can choose what they will do. So every year, it's a choice. And this is actually the baseline, the range of choices they have against the intervention that they will make, which will be actually the nitrogen stabilizer. As for the quantification, there are two kinds of emissions that we are accounting for. The production emissions, which to account for them, we require a product carbon footprint or a life cycle assessment. And then there are the direct and indirect N2O emissions, for which we give three options. The first one is a difficult one. It's doing direct measurements on the field, which of course is only applicable for the land management unit. And this is a tough one because it is a very expensive method. However, we decided to keep it in as an option because we would like to assist farmers who have access to this kind of tools to measure their impact. The second is using scientific literature, meta-analysis, or specific studies that are relevant for their situation. And the third one, as Sijbrand mentioned, is the IFA emission factor database that is currently in development. And it's basically a way to streamline the second step, so the scientific literature, and provide standardized, aggregated emission factors for very specific situations that are interesting. For example, for specific stabilizer products, for specific regions, soil types, etc. Next, as for the quantification, Tier 1 emission factors are only allowed for indirect emissions. And by indirect emissions, we mean, of course, the ammonia volatilization and nitrate leaching. So for the direct emissions, Tier 1 emission factors are not allowed, and we require project developers to go into more granular emission factors where we know about the soil types or regions or temperature, precipitation, these kind of factors. Lastly, regarding the monitoring, reporting, and verification, we have given different requirements based on the type of special boundary that is required. We ask that the evidence that is supplied is science-based, especially regarding the emission factors, and we allow for multiple interventions, as mentioned before, specifically for the LMU type of projects. And finally, before we move on to the Q&A, I would like to show you an example of how we think this methodology could be used to support the adoption of stabilized fertilizers. For the first case, the land management unit, It is the case where we know where the stabilized products are applied. So you can see the farmer in the middle, who are growing specific crops, and then they are selling them to certain crop buyers. This is a very direct approach where you know what's happening on the field, you know who the buyers are, so there is a very good connection there. On the other hand, you have the sourcing region, where a fertilizer company or a distributor of fertilizers knows the regions or demand sets of where the fertilizers might be applied. And they can group the specific regions of where those are applied and create essentially a distribution of the soil types and the crop types, and based on that, calculate the emission reduction. So you can see that those two types of projects are very different, because on the left side, this could be driven by either an agricultural farmer cooperative or even the crop buyer industry, the food industry. But on the other side, we do not have information about what's happening on the field. We just know in which regions the fertilizers are sold. So a fertilizer company or maybe a distributor of fertilizers could be the one driving the impact. I think that's it, and I hope I have left enough time for a Q&A, which I think I can give Sijbrand the floor to now.
Yeah, thank you very much, Konstantinos, and very well done. And thanks for the concise overview of the most important topics in the methodology. And thanks for all the people who are still there. Maybe, yeah, we see a few questions already in the chat. Some of those are actually answered by either us or Achim, and I think also Gregor was very active. So thanks for that. Maybe to start, I want to stress that after the webinar, we will share the methodology, we will share how you can give feedback, and we will make very clear on how that can be done and what kind of feedback document will be available to you. So that will be very clear after the webinar. But maybe there's a few topics which I think could be interesting to kind of talk about in a more Q&A type of form. And if okay, Achim, I start with you. There are quite a few questions on the economics of things, so the cost of things, and so basically the added cost of adding a stabilizer in a farmer context. So maybe you can talk a bit to that topic and discuss or express how we thinking about that.
Yes, I'm not neither a businessman nor an economist, you know. So, but obviously, anything that costs a lot but doesn't recover the cost through additional yield or product value will have difficulties in finding wide adoption. Yeah, we know that, and that's also been a major constraint for the adoption of inhibitors or controlled release fertilizers or other types of products. You know, so the market share is still relatively small compared to the bulk fertilizers that constitute most of the nitrogen market. You know, so. And of course, in some cases, regulatory requirements may require the use of these products, but that more or less transfers the cost to the farmer than to absorb, you know. So what we're hoping to do here is to create a market-driven incentive, as it was explained, hopefully, in some cases, at least where such markets exist, and there are buyers for such credits who want to reduce their carbon footprint, such as food companies, for example, that through an effective mechanism, such credits can be sold to them, and the money, to a large extent, goes back to the farmer to cover some or a significant part or all of the extra costs. Now, how that works and to what extent that cost can be replaced or substituted through these carbon market payments, you know, is the unknown question, you know. And we also don't know yet really, and it will also depend, of course, on the different where you are in which region or country, and the market forces and the market prices and everything, you know. So it's not I don't think one size fits all solution that will be market driven everywhere. So it may still also benefit from other support and where it is needed. There were also in the chat questions that particularly relate to developing countries and smallholder agriculture there. Now, I think let's start with Africa. I think let's put it this way. The primary problem in Africa is not inhibitors. It's the need to have more fertilizer first before you can start thinking about a more sophisticated solution of this kind here. But there are world regions where in smallholder agriculture we already have a long time and also substantial use of fertilizers and associated high nitrous oxide emissions in parts of Asia, for example, where it would make sense to also now add this component to it. I think this requires then, of course, an efficient aggregation mechanism because you need to get the numbers right in terms of hectares or tons that you mitigate, and that mechanism, how do you generate this up from thousands of smallholder farmers in a certain region, is another one of these challenges. But my personal view on this, and I've said this at the beginning when we had these project discussions 2 years ago, almost, or more than a year ago, is look, we can be skeptical about this, but we won't know until we try. So I'm always in favor of finding a solution around the problem rather than talking about the problem. And here, I think what we're hoping to come up is a really workable methodology that, from an implementation point of view, is doable without creating a massive amount of bureaucratic burden, and at the same time, hopefully also scientifically sound and evidence-based. There will always be big uncertainties in terms of what you can claim and how you verify it. But I think we'll learn by doing, and I think specific use cases that we hope to do in different settings will guide us a lot towards that.
Thank you very much, Achim. Thank you very much. So many questions are still coming in, so thanks for that. I want to try to start answering a more technical question, questioning to Konstantinos. So I think those are related. Will you set a threshold with regards to the minimum of N nitrogen efficiency reached? And I think a related question, if I understand correctly, let me try to find it, is will there be best management practices published with the methodology? We assume at farmer level.
Okay. So, will you set a threshold as regards to minimum nitrogen, I assume, use efficiency is reached? So, what we require is that the nitrogen use efficiency of the project is at least as good as what is happening for similar situations in the region or the wider area. So, as I mentioned before, we do not want to overestimate the impact, and we do not want to allow projects to gain more credits because they have been over-applying nitrogen. So, for that reason, we have added in the methodology a requirement, performance test of testing the nitrogen use efficiency of the project compared to what's happening in the region. So it is a little bit dynamic in that sense. It's not a specific nitrogen use efficiency because that depends very much on what kind of crop you're growing, in what region, soil type, everything. So the list would be huge, and we are kind of placing the burden to the project developer in that sense. And the other question was?
About best management practices.
Well, we did not have any plans to add specific best management practices outside of the addition of the nitrogen stabilizers, because that is the focus of the methodology. How you add them specifically, it really depends on the cropping system that you have. In some of them, it might be best case to use a stabilized nitrogen fertilizer. In other cases, it might be best to add them before, after, in liquid form, in other times. So it highly depends. And if we were to try to create a comprehensive list of every possible best management practice, the methodology would not end. So we are once again placing this burden to the project developer to ensure that the management practice that they're doing is actually aligned with the best practices in the region or for similar cropping systems.
Thank you. Thank you very much. I'm going to pick one more question for Achim. Achim, I hope you can answer it, but let me know if we can help. So one of the questions is, when will this IFA emission factor database become available? Can you shed some of your light on this, please?
Oh, it's actually almost maybe for Konstantinos to answer. I mean, the first answer to that question is that such a database is never finished. So we will use it to generate a first set of emission factors as part of the methodology sometime later this year. But that can only go to a certain degree in terms of disaggregating by product categories or regions or combinations of things. So, and then we would hope that over time, as more data can be added and analyzed, we can slowly move down to more specific factors at the tier 2 or even tier 3 level that could be more applicable than to specific claim situations. So that work, I think, will be a process that continues over time, but let's assume that the first factors will still become available this year when the methodology gets released.
Thank you, Achim. Okay, maybe one more question before we start to slowly finish this webinar. For you, Konstantinos, and I hope you can answer this question. There's quite some interest on this question, apparently. I think we touched the subject also during the project, that the design and development of the methodology. It's around the parts per million in the actual product, specifically in commercial products in the US. Is there any guidance there that the methodology will give on potential participants in creating these product interventions?
So I think it's very important that those questions are asked, because it is actually one of the biggest problems that we have been dealing with when designing this methodology. And the problem is it goes beyond the fertilizer and the stabilizer industry. It goes to the scientific community. So the problem is that even when studies are published with the aim of understanding the impact of these stabilizer products on emissions, it is very typical that they do not mention what kind of concentration the active ingredients have within the stabilized product, which means that there is little understanding on the effect of the concentration of those ingredients on the emissions. And this is a clearly scientific problem, and I think it has been addressed many times in the literature. So it is also kind of a call to action. But the best we can do right now is two things, and what we are doing right now in the methodology. We require first that project developers look what the stabilizer producers are giving us recommendation on the application rates of these products. In the case, for example, that the stabilizer is sold separately to the fertilizer, you could put more or less. However, the producer has done typically many tests on the impact of those emissions or a nitrogen use efficiency. So you can use those guidelines as a starting point. That's one. The second is looking at regulation, what is allowed, so that we do not over-apply a specific component. And the third is trying to find studies which have actually mentioned the points per million for those kind of products. But this is indeed an issue that needs to be very carefully managed by the project developer as well.
Okay, thank you very much. Then, yeah, considering time, we have 2 more minutes, so I want to close up the Q&A and thank everybody tremendously for the participation and attention. Maybe the next slides we can still show, Konstantinos. So again, the main goal for today is to get more feedback. So in order for you to provide feedback, I once more will share the methodology in the chat, so you can download it on our website. And there's also the feedback document that you can find, so please use it and ask any question that you have. Thanks again. And well, we hope to get a lot of feedback, and we'll, well, of course, keep you updated on any of the progress that we make because of it. Other than that, I want to thank you all for joining this webinar, and hope to talk or well, see you in all kinds of digital forms later on. Maybe just making sure the next slide. Yeah, one more. So we will share the deck, and we will share the recording, but we will also share the email addresses. So there's an official consultation email address where you can submit your feedback through the official channels. But we also want to, well, make sure that you can reach us personally. So please reach out if you have any more questions. Thanks again, and hope to see you all soon.
Thank you.
Bye.